Today we are looking at 3.2 quadratic equations, functions, and zeros. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c is equal to 0. And this is your standard form. It's written in standard form. And then your quadratic function starts with your function a f of x is equal to ax squared plus bx plus c. A, b, and c are real numbers. A cannot equal to 0. We are going to start by solving quadratic equations by factoring. So the first problem I have is x squared minus 3x is equal to 0. So I need to see if I can factor this. I have two terms. So I see if do I have anything that's common. So there's a common x I can take out. Now, once I have everything in factored form, I need to solve for x. I said x equal to 0. X minus 3 is equal to 0. So x is going to be 0. And the second equation, I solve for x, so x is positive 3. In the second problem, I need to get my equation in standard form. And I know that means that my x's and my squares and everything have to be on the same side and in order. X squared comes first. I move a negative 2x over, negative 15. And now the equation is going to be equal to 0. Everything is on one side. Now I see if I can factor. So I factor that to be x minus 5 and x plus 3. The factors of 15, that's going to give me 2, or 5 and 3. 2 is negative, so therefore my larger number has to be negative. So I get negative 5. Now I set each quantity equal to 0. Solve for x. So in the first one, x is going to be 5. And the second one, x is going to be negative 3. In the third problem, I look to see if I can take any greatest common factor out. It doesn't appear that I have any common factors. It looks like that I have the difference of squares. So I want to factor my two binomials. So I get 5x plus 3, 5x minus 3. Now set each one equal to 0. Solve for x, so x is going to be negative 3 over 5. And x is going to be positive 3 over 5. So whenever I need to solve by factoring, If I have two terms, I look for a common factor or the difference of two squares. If I have three terms, I want to put the x squared x and my constant on the same side and have that equal to 0 and make sure it's in descending order. The second property that I'm going to look at is my square root property. If you have, then I can solve for x by taking the square root of both sides. If I want to solve for x squared and I'm looking for x, I need to take the square root of both sides of my equation. So then I have x is equal to square root of k, or x is equal to negative square root of k. So in order to solve by square root property, the first thing I need to make sure that I isolate my x squared on one side, and it seems like my x squared is isolated already, so I square root of my x squared. Then I have to use plus or minus because I don't know. I have a positive solution and a negative solution. So I can plus or minus the square root of 49. Square root of x squared x is equal to plus or minus the square root of 49 is 7. Then I have x is 7 and x is negative 7. Now in the second one, I need to factor out a 3. And now I have x squared plus 5 is equal to 0. So I need to get my x squared alone by itself. So I move a negative 5 over. And now I can take the square root. The square root of x squared is x. Now we know that whenever we have negative in a square root, a negative 1 is equal to I. So I can take out I. And then I have the square root of 5. I cannot break that down. So that's my final answer. X is equal to plus or minus I, the square root of 5. Here it's written a little differently, but it's still, my x quantity is still being squared. So I take the square root of it. Take the square root of both sides of the equation. So then I have x minus 2. The square root of the quantity of x minus 2 squared will just give you that quantity that's inside, which is x minus 2. Plus or minus, I could take the square root of 25, which is 5. X. Now I need to move a positive 2 over, so I get 2 plus or minus 5. Now a lot of students would just leave it written like this, but I have x is equal to 2. I need two solutions, so x is equal to 2 plus 5, which is 7. Then I have x is equal to 2 minus 5, which is negative 3. So when we are using the square root property, we have to isolate the x squared on one side by itself. And we see most of the time we have two terms. So once you isolate it, then you want to see if you can factor anything out. Now looking back, I just want to look back at this problem, 3x squared plus 15 equal to 0. You can have set that equal to, you could have isolated your x squared, your 3x squared term by itself first if you wanted to, and then divide out by 3 to get x squared to have a coefficient of 1. And then you just take your square root plus or minus on both, square root on both sides plus or minus on the right side, and then x is equal to plus or minus I radical 5. So you can do that like that instead of factoring out the 3 first. The third property that I'm going to look at, the third method, is completing the square. So there's a lot of steps in completing the square. So in order to complete the square, you want the coefficient of your x squared has to be 1, and the coefficient is 1. So if it wasn't 1, you would divide out by whatever coefficient that is, but we are going to give you 1 that the coefficient is 1. And the thing I need to do, I need to isolate my x squared, my x term. So my x term has to be on one side by itself, so I need to move my negative 2 over. So x squared and x are alone on one side. Anything that's being added or subtracted, you move it to the equation. And now once I have my x squared and my x term on one side by itself, I take half of the coefficient, my middle term. So I take half of 6. I can take half of negative 6. It doesn't matter because my answer is to be positive anyway once I do the next step after taking half. So if I get half of negative 6 is negative 3. And then once I take half of that, I want to square my answer. Negative 3 squared is 9. So I need to take this number now and I want to add it to my left side and my right side. So it's going to be added on both sides. It's always added. So when you square it, it doesn't matter if it's negative or positive, you're going to get a positive answer. So now you square it and add it to the left and right side. Both sides get a positive 9. So now I want to factor this trinomial. I want to factor. So I get x minus 3, x minus 3, and I simplify the right side. I get 7. Now these two binomials should always be identical when you factor. And now I can rewrite this as a square of a binomial. So I can write it as x minus 3 squared. And now I have this x in parentheses, and the only way that I can get it from there and get that quantity alone is by taking the square root of that expression, and then I want to do it to the other side. So now I have x minus, that just comes out the radical. X minus 3 is equal to plus or minus radical 7. Now I just don't leave this like this. Students like to just stop here, but I'm always solving. I'm solving for x, so I have to get x on one side by itself. So I move a positive 3 over. I have positive 3 plus or minus radical 7. I cannot do any more with that 7 that's in that radical, so my final answer is going to be x is 3 plus or minus radical 7. And if I wanted to write x is plus radical, or x is 3 and that's completing the squares. So it's a lot to take in. So again, a recap, your coefficient of your x squared has to be 1. And in this problem, it's perfect. Now I just need to isolate my x squared and my x to one side by itself by moving that constant number to the other side of the equation. And then once I do that, I take half my coefficient of my middle term. It could be the negative or positive. It really doesn't matter because once I square it, that number is going to be positive anyway. So I take half of my negative 6, which is negative 3, and square it. I get positive 9. And if I add something to one side of an equation, I have to add it to the other side. And then after I do that, I need to factor my perfect square trinomial. The two binomials are identical at this time, so I can rewrite it as x minus 3. Well, the quantity of x minus 3 squared. And then in order to solve for x and get x not to be wrapped up in that square, I take the square root of it. And if I take the square root on one side, I take it to the other side. I take the square root of the other side also. And then I just solve for x. The fourth type of property that I'm going to use to solve quadratic equations is the quadratic formula. So I have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So the whole quantity is over 2a. Now let's see this in action. So in order to use my quadratic formula, I always need to have my equation in standard form. So in this first one, I need to move a negative 2 over. So I move a negative 2 over. Now I need an a. Coefficient of x squared is a. B is a is 5. The coefficient of my x is your b, which is 3. And my c is my constant, which is exactly how they have it is a negative 2. So my c is a negative 2. You take the signs also when you determining your a, b, and c. So now I just put these numbers in for my variables. So I have a negative b, which is negative 3 down, plus or minus 3 squared. I always write it in parentheses, whether it's positive or negative. So I always write my b squared in parentheses. So to make sure when I square it, I get a positive number. Minus 4a, which is 5. And c is negative 2 over 2 times 5. Now I need to simplify everything that's in my square root. So I get 9. 3 squared is 9. Then I have this negative. This is a negative 4. So negative 4 times a positive 5 times a negative 2 is going to give me a positive 40. So now I have negative 3 plus or minus the square root of 49 over 10. The square root of 49 is 7, so negative 3 plus or minus 7 over 10. So I have to simplify that 49. And now I do not leave my answer just written like this. It looks weird, so I need to expand it out. So I get negative 3 plus or minus 7 over 10, which is 4/10, which is 2 over 5 when I reduce it. So one answer is 2 over 5, and then the other one I get negative 3, negative 7 over 10, which gives me negative 10 over 10, which is negative 1. So my two answers, 2/5 and negative 1. And just note that negative gave me negative 3 and negative 7 gave me a negative 10 over 10. And reduce that, you get negative 1. So in order to start the quadratic formula in form, my x and my constant term have to be on the same side, and then I set that to 0. My coefficient of my the coefficient of my x squared is my a, coefficient of my x is my b, and my c is my constant. And I just plug it back into the equation. Now the second one, I'm still using the quadratic formula, so I need an a. A is 1. B is 1 and C is 2. So now I know my formula. I get negative 1 plus or minus b squared minus 4ac all over 2 times 1. So now I just simplify what's in my radical. So I get 1, a negative 4 times a positive 1 times a positive 2 is a negative 8. 2 times 1 is 2 all over 2. So now I have x is equal to negative 1 plus or minus radical negative 7 inside 1, and a negative 8 is a negative 7 over 2. Now I look inside the radical. I can take out I because I know that the square root of negative 1 is I. I take out I because I also want it to be positive inside my radical. There's nothing else I can do with that radical 7, so this is my final answer, negative 1 plus or minus I radical 7 over 2, and I can write it as 2 solutions if I want to. And that's how you find your quadratic formula. And also, we can also, I don't know, sometimes you can even separate it with the fraction if you want to, negative 1 half plus or minus radical 7 over 2. Sometimes you make I in the math, but you just have to check with my math lab or any app that you are using to input your problem, your answers for your homework. To find the zeros of the function, so the zeros of the function are the numbers of x that makes the value of a function equal to 0. So what we want to do is we want to take this function and set it equal to 0. And this is how we would find what x is. Because once we input x, x will make that, whatever x is, that x will make that function 0. So we need to find the zeros of that. Well, we need to find the x's that would make the function 0. Something like that. So I need to factor first. So once I factor, I get x plus 5x plus 1. Now set each quantity to 0. Solve for x. So x is negative 5, x is negative 1. So if I were to put these back into the equation, I would get 0. So to find the zeros of a function and they give you the function, you just set the output as whatever you have and then set that equal to 0 and solve for x, and those two answers that you get are your zeros of the function. So your zeros are negative 5 and negative 1. So you would write it out as negative 5 and 1 are the zeros of the function. Sometimes we can look at a graph and see the zeros of the function. So the zeros are always your x coordinates of your x-intercept. So when I look at my graph, I need to find my x-intercept. And the x-intercepts are where y is 0, or where the graph touches the x-axis. And at that point, y is 0. So it looks like 1, 2, I would say this is negative 2. It could be 1, 2, 3, 4, and I'll make that a positive 4. So it looks like my x-intercept is negative 2 and 0 and 4 and 0. Now, once I know my x-intercepts, I can easily find the zeros. The zeros are just the x-coordinates of your x-intercept. So my zeros are negative 2 and positive 4. So that's how you find the zeros of the function. So for my graph,